Thanks to the organizers for giving me a chance to talk with you about communication today. This is going to be something completely different. Pardon my voice, I have allergies. No charts, no graphs, no quantitative analysis. We're going to be talking about communication. For those of you who don't know me, my expertise is in communication. I'm a social scientist. I'm currently working as a consultant to the astrobiology and near-Earth object observation programs at NASA headquarters on communication issues. And today I'm specifically focusing on the challenge of explaining asteroid impact hazards. And I'm going to talk about responsible communication about science and risks. Just a little background, I think most of you probably know this, but in very recent years, the NEO program has grown monetarily by leaps and bounds, although it's still a very small program, and yet it's tasked with a lot of important work to do. And we now have a role in this broader initiative, the Asteroid Initiative. And I'm going to mention other events. That's a very loose description of the things on this list. But just this increasing attention and focus on the near-Earth object environment and the risk of impacts with Earth. And of course, asteroid impacts have been a part of Earth's history for the entire existence of Earth, but it's now a serious risk because of our built environment and our billions of people on the surface. So we have our most recent National Research Council report, Defending Planet Earth, focusing specifically on the planetary defense aspects. We had a Secure World Foundation, Association of Space Explorers, a workshop on risk communication about near-Earth objects, and that was held in 2011. That was my first in-depth experience in talking with other experts about the issues. We've had a recent congressional hearing about the near-Earth object program and planetary defense. We had our most recent biennial planetary defense conference in Arizona last year, and we'll be meeting again in Italy next year. And that's a week-long event. It's fascinating. It's like going to graduate school for a year in a week. B612 Foundation, of course, is trying to crowdsource funds to build a dedicated NEO search telescope, space-based telescope, which we don't have yet. I may or may not have time to talk about this fall event, a media event, which generated a lot of misconceptions about what's been done and what's not been done and what we know and what we don't know. We've had two NASA FEMA, Federal Emergency Management Agency, tabletop exercises where we work through scenarios developed by the community for asteroid impact events, very realistic scenarios, and we've learned a lot of important things relating to communication, along with other things, working with our colleagues at FEMA who speak a very different language than the neoscience community does. And I will get back to that in a couple of minutes. The International Asteroid Warning Network has been organized in response to recommendations from the United Nations, working up from a working group to a subcommittee to a committee. The steering committee for IWAN, as we call it, had its first meeting in Cambridge, Massachusetts in January, and I was asked to organize a panel on communications, and that panel discussion generated a lot of discussion amongst members of the steering committee, which led to a recommendation to hold a dedicated workshop on communication issues for the IWAN, and we'll be holding that in Broomfield, Colorado in September. This is some specific advice from this most recent NRC report, and you'll see this is my emphasis added. Assessment of statistical risk from asteroids needs to be reasonable and acceptable to the general public. That sounds perfectly reasonable and sensible, but it's not easy. And again, careful assessment and explanation of hazards. These are some points that came out of, we have a report now published by Secure World Foundation on this workshop. Again, make use of the findings of experts in risk communication. We had 3 social scientists at this workshop, and we kind of banded together. We were all in the same place and trying to persuade our colleagues on the science side that we had something to offer that would be useful to them. And I think over time, I've been working with the NEO program for only 2 years, astrobiology much longer, and I've already seen considerable progress, so I'm hopeful that we can address these challenges successfully. But very often, this is what we end up with. We get a lot of statistical analysis. We get a lot of jargony expertise. And again, our experience with our FEMA colleagues has been very helpful because we're basically talking equal to equal, and they're saying, we don't talk like that. You have to find another way of explaining what you're doing. And here's some specifics from our first tabletop exercise. We're working on the report from this year's exercise, which should be out a little faster than this one. This one took a long time to go public for a number of reasons. And again, this emphasis on improving tools for communications. I have to tell you that my impression of FEMA today is that they've come a long way since the days of Brownie and the Bush administration, and their communication people understand what works and what doesn't work in communicating about hazards and risks. So I think this partnership between NASA and FEMA will be very fruitful as we proceed. And FEMA is well along the way to putting asteroid impact hazards on its list of hazards it needs to be prepared to deal with. And this is, again, some points about communication that came out of our week-long conference, Planetary Defense Conference in Arizona. And this challenge of international communication response, which is a task that the IWAN is taking on, it's more complex than even on the domestic front because we're dealing across cultures and across language barriers. But again, I think it's doable. And that's something that the IWAN will keep working on, and we'll really get into it. This relates to the picture on my opening slide. I wanted to show some pictures, artist concepts. These are things that no person will ever see. But this is the kind of imagery we use when we're talking about asteroid impact hazards. And of course, mass media love these things because they're colorful and dramatic. What does this mean? You know, I mean, to the general public, of course, you know, non-experts, I like to refer. And again, here, this is not anything anybody would ever see. But this is how people outside our own community tend to think about impact hazards because this is what they see. And I think that we might consider using more realistic imagery to talk about, this is, of course, after Sandy, not exactly analogous, but to show real damage. This, of course, was taken years and years after the impact, but it's real damage. People can relate to it. It's on Earth. And again, this is an actual photograph of the most recent tsunami in Japan and an artist concept of tsunami effects. Yeah, again, dramatic, right? Woo. Right. But whatever we can do to provide more realistic imagery to get our points across about the possible effects of impacts. And even such a simple thing as explaining what we mean by impact. When we talk about impact, we're talking about atmospheric or ground impacts. But most people think of impact as hard object hitting a hard object. So even something as simple as that, I think we need to explain a little bit better. I want to talk about this particular comparative case, and I would call it not so much a lessons learned case because it's not completely transferable to the NEO community, but I would describe it as a cautionary tale. Some of you may have followed this story of the L'Aquila earthquake case, but what I got interested in is the court case and the court decision and the fact that this panel of 7 experts appointed by the government to assess hazards and risks of earthquakes were all convicted and jailed for not bad science, but bad communication. And my understanding, reading the judge's decision and reading statements of the public prosecutor in this case, that they were explicit, that they were not convicting these scientists of not being able to predict the earthquake, but of bad communications. And the sad news is, to me, that it was really this guy, Bernardo de Bernardino, who either didn't understand the science. This board is made up of civil defense officials and geophysicists. They're the equivalent of our NASA-FEMA collaborations, although I think those are working much better. But in this case, this was put in writing that the civil defense officials were in charge of public communications about risks and hazards. And this guy really blew it. He's the guy who said, go home, drink a good bottle of wine, make sure it's a Barolo. And people didn't leave their homes and people died. And again, it's fascinating to read the court documents and also media coverage. There's a guy, I can't remember his name now, but an Italian journalist who put together a fabulous website with lots of Italian newspaper articles translated. And it was very helpful to me in thinking about this. Perfect timing. I wanted to have 2 minutes to talk about this last slide. And these are things that I would just ask you, if you're willing, to think about in thinking about communicating responsibly about science and risks. What are your goals? I think very often we don't think in advance about what we're trying to accomplish in our communications. We tend to think of ourselves as experts, and our job is to convey our expertise to non-experts, but it's much more complicated than that. Are we trying to educate people? Are we trying to inform them? Are we advocating for a particular program? Are we advocating for funding to move research in a certain direction? Are we promoting a certain kind of ideology in the communications that we're engaging in? Are we attempting to persuade people to think like us or write their congresspeople? And whatever you choose, that's your business. I'm just asking you to think about it in advance. What are your goals? And to be aware of what your goals are. And it would be nice if we would think about what sort of ethical framework we might want to apply to govern our discussions of risks, benefits, and I put facts in quotes because I'm a social scientist and facts are constructed, and uncertainties. And my recommendation, and not just me, many of my colleagues in the communication field, would be to go for moderation, to curb your enthusiasm. We have a lot of cheerleading going on in the space community, which may or may not be useful depending on your goals. That's not my goal, to cheerlead for anything. My goal tends to be informing, just if you're interested, to be accurate and complete, and to be clear about your intentions. And this issue of stealth advocacy, this is an idea that's developed by some colleagues of mine in the field of communication. And it relates particularly because lots of money's been available for science communication research relating to climate change, so we have lots of research on climate change communication, that if people perceive you as advocating for a particular course or a particular choice or option, but you don't acknowledge that you're advocating, you don't acknowledge that you're an advocate. And this has to do with climate people who are lobbying against the idea that governments need to put some serious money behind climate change research and climate change adaptation, who say that scientists are biased. They're all Democrats. They all want money for their work, and they're just advocating to continue their research. But it's a matter of perception. Perception is reality. Our perceptions are reality. And if people perceive that you are stealth advocating, it can undermine your credibility and inhibit your ability to develop the public's trust. I'll stop there and hope we can have some questions.
Thank you, Linda. Any questions? There's a question there, Ben.
Dan Britt, University of Central Florida. About your example of the Italian seismologists who ended up being convicted of manslaughter for giving an honest answer. They gave an honest answer. They gave the best science they could. And people died because, of course, there is always a risk there that even your best is not good enough to save lives. Yeah. And the history is populated by people who have given honest assessments of risk and ended up being wrong this time, but based on the best possible science. Yeah. So just an observation that it's certainly also possible for prosecutors and juries to be completely irrational in their perceptions of science.
I agree with you, and but again, this is a fascinating case, and I'm not sure it's generalizable to any other situation. But did you happen to read the letter from one of the imprisoned geophysicists in Science magazine? That was a heartbreaking letter. I couldn't include it here because I had limited time to cover the material. But he actually, it really was heartbreaking because he said, you know, the court officials misunderstood my science. But the problem is that gap between scientists feeling he's being responsible and explaining his science and the non-scientists on the other end, let's just call them non-scientists, needing more explanation, more interpretation, more context for the work. And so I'm not pointing the finger one way or another, but it was just a heartbreaking letter. If you haven't read it, Enzo Boschi is the guy's name, and it just broke my heart to read it.
Yeah, I read that letter, but the problem is that people want more than you can provide. And one thing I would urge is to include in that slide an honest answer.
Yes,
you know, honestly, what you can provide. I gave a talk on earthquake prediction to a general audience. And I said, well, there's going to be a magnitude 8 earthquake in California in the next 30 years. And they said, well, but that's not going to do us any good. I said, well, that's the best science can provide. And if you want to know which weekend to not go to California, I'm not the right person to talk to, and no scientist is.
Yes. And
just because you want a better answer, it doesn't mean that a better answer exists.
So you are our shining example of the way to do it. There's too much, and I'm talking broadly here about the science community.
I would deny I'm a shining example of anything.
But there's a tendency in the science community, when you're speaking across that expert, non-expert boundary, to leave out the gray stuff, to leave out the blurry stuff. What we need to do is get comfortable talking with any audiences, including decision makers and policy makers, about uncertainties, and to acknowledge uncertainties. And sometimes people feel that that puts them at risk. You see what's happened in the climate change field, where discussion of uncertainty gives opponents an opportunity to stick their fingers in your arguments and see they don't know. But we have to do that. I mean, for me, it's an ethical consideration, and you're doing the right thing.
Well, thank you. I know, Tim, you need to ask your questions, but I'm not sure we have time. I certainly encourage you to have conversations during the poster session and afterwards. This is something very thought-provoking, not to mention conversation-provoking.